Okay, so yeah, let's start. Thanks again for the invitation. I'm glad to be here. So today's topic is all about Azure DevOps. I know you're in a series of infrastructure as code, but the Azure DevOps basically is agnostic to if I just deploy infrastructure based on infrastructure as code, if I'm just compiling something and deploy the app, etc. So we will have a look at many generic concepts, but I always try to point to the infrastructure side of you if you're going through the topics. So what is it all about? What are we going to do this evening? So first of all, I like to provide you an overview of Azure DevOps. What is it? What's the ecosystem around it? How do I use it? What can I do with it? Then we will go straight into YAML pipelines. So YAML pipelines, or YAML, is the new format of defining pipelines, meaning automating things in Azure DevOps. That's what we need to create packages, to automate deployments, to interact with Azure, etc. Then we'll have a look at variables and secrets. So especially in infrastructure deployments, you deal a lot with secrets, variable settings, etc. So it's important to know what can I do with variables and secrets. Then we'll have a look again at agents. So agents are the processes running your automation, basically the task runners behind Azure pipelines. There are a couple of different, or you can deploy agents in different manner for different purposes. So we'll have also a look on that one. And then we'll have a look on environments. Environments is a new feature. Maybe you already have seen it in GitHub as well, so it's the same concept behind it. So how do we control logical environments? What are the benefits of using environments in our automation? And last but not least, if you have time, I also like to talk a little bit about containers in pipelines. So basically getting infrastructure as code into the pipeline itself. So how do I set up the build agent? How do I set up the tooling? How do I set up the deployment tools? You could do that as well with containers based on Docker containers running in the pipeline together with the agent. But hopefully we have time to cover everything by today. At the end, we have a Q&A session. Please feel free to interrupt me anytime if you have a question just about the slide I'm presenting or about the demo I'm doing. So just raise your voice or send me a chat message during the presentation. Okay, then let's get started and see what's it all about. What is Azure DevOps? So from a very, very high level point of view, how is Azure DevOps structured, or what is Microsoft's DevOps tooling, at least? So it's not only the Azure DevOps. We know it as a product. A lot of people know it as TFS. Then it was Visual Studio Online, etc. So what is this Azure DevOps? Most of you probably heard about those 5 modules we get in Azure DevOps. So we have Azure Boards as a module. It's all about agile planning, structuring your work, and do also the whole traceability. So what requirement was deployed, how many tests did we run regarding that requirement, etc. This is all packaged into Azure Boards. So all the backlog planning and sprint planning is in there. Then we have Azure Repos. So it's about organizing, versioning your source code. Currently, we have 2 different providers available. So it's either Git, which is the new one and is also the preferred one, because if you're not using Git, you're missing a lot of features. So mainly 80% of this presentation you're missing if you're not using Git. So if you're using Team Foundation version control, it's still there, it's still supported, but all the new features towards like YAML pipelines or the new fancy stuff, it's all based on Git. So basically, there's a need to actually migrate to Git if you really want to get most of Azure DevOps. But again, if you have old projects, you're still able to use Team Foundation version control within Azure DevOps. Then we have Azure Pipelines. So this is the whole automation thing. We're doing most of the presentation in this module. So if I want to do an automation like compiling code, generating some packages, deploying things to Azure, verify something like doing some system integration testing, and so on, this is all based on Azure pipelines, and this is the main part of today's presentation. Then we have Azure Artifacts. Azure Artifact is basically a service to provide you feeds to store NPM packages and NuGet packages. And in the cloud service, they also offer universal packages. So universal packages is basically a version zip file. You can use it the same way as you use NuGet or NPM through a feed. So you have the whole feed security with the versioning, etc. And there are some special features implemented. Basically, if you have really, really large packages for deploying a huge application or a huge infrastructure, they have mechanisms applied that the up and download of package updates only upload and download a diff of the package, so it's changed, so you have a local cache, etc. So it should be quite fast. And last but not least, we have Azure Test Plans. If you're into traditional test planning, test case management, test plan management, this is the module for you. So you can really do your test planning inside Azure DevOps. So if you're talking about deploying things to Azure, and this is mainly the topic of today's event, there are more modules, but you have to see that it's not really in the product Azure DevOps, it's in Azure. And more new features are packaged together with Azure DevOps, but are not in the main product. They're basically isolated or independent Azure services, but with a very, very tight integration into Azure DevOps. So as you can see here, we have, for example, the App Center, which is a simplification of CI/CD for mobile apps. We have Azure Dev Test Labs to easily set up VMs used for testing. So if you need a VM, for example, to deploy your application to run some UI tests and then delete it, Azure Dev Test Labs simplifies that a lot. We have a very tight integration into Azure Kubernetes services. So it's one of the main deployment targets, actually, with the most features in Azure DevOps to do special deployment strategies, etc. Those are all implemented for Azure Kubernetes services. You have integration for Azure Security Center and Azure Monitor, Azure Policy, and last but not least, Azure Key Vault. So if you're dealing with secrets, we will see that there is a way of storing secrets inside Azure DevOps. But if you're used to use Azure Key Vault, there's a seamless integration into Azure DevOps as well. So basically, there's a variable coming up for you, which is read from the Azure Key Vault, but it looks like it is a normal Azure Pipelines variable in your deployment process. You also have some cross-cutting features like dashboards. You can define dashboards for your team, the latest KPIs of your projects. We have a fully integrated wiki inside Azure DevOps, which is also capable of integrating parts of another Git repository in your wiki. So for example, if you have a overall company wiki and then you have some code documentation of your projects, you can basically link Markdown files of your code repository inside the wiki and have a single wiki experience inside Azure DevOps. And then we also have analytics. So whenever you need some metrics around your deployment, how many times it failed, what's the overall mean time of something, this is where you go. So you can easily generate graphics and dashboards out of analytics. One thing to note, we heard it all the last couple of months, etc. GitHub is there. So there's a second tooling in the Microsoft DevOps world, and they have some overlap. Currently, it's not that they are that they have the same features overall. So Azure DevOps still targets a little bit more the enterprise scenarios. So for example, the Azure boards has a lot more planning capabilities than the issues on GitHub. But we see that both of them, or basically that GitHub is getting more and more features, like we're seeing GitHub Actions, which is basically a new way of using Azure pipelines. So features like multistage pipelines we only had in Azure DevOps are now also available in GitHub, etc. So it's really currently a side-by-side tooling, and you can easily integrate GitHub as well. So if you think, yeah, I want to have my Git repositories in GitHub, but I still want to use Azure pipelines because I've got some nice features over there, it's seamlessly integrated. You do not really notice it. So it's doing all the tricky things behind the scenes. So if you click edit pipeline, it does an edit in your GitHub repository seamlessly, etc. So they can coexist, and currently you really have to choose on the available modules which best fits your needs to decide what should I use currently. Okay, so enough about the overall tooling, just as an overview. So how do we use now Azure DevOps in regards of deploying your infrastructure and also deploying your apps in the deployed infrastructure? So basically what we have is, normally we have app code, your microservice, your whatever app, and then we also have the infrastructure definition, usually defined as infrastructure as code as an ARM template in terms of scripting like Azure CLI, or even you have code like Pulumi, whatever. So you have some kind of infrastructure definition. And what we need to do is we need to create Azure resources, deploy them, use them, run our apps on our created resources. So what do we need Azure DevOps for? So first of all, we need to manage all our artifacts. So basically we need versioning, we need branching to develop our infrastructure, our apps. Then we need some kind of creation, like compiling the code, create some packages out of your infrastructure definitions, and then we deploy it to Azure and create those Azure resources. From the tooling perspective, how does it look like? What do we need? So first of all, we need some kind of task runner. So there are many different things we need to do, like creating the package there, compiling this, test this one, run a deployment script, interact with Azure ARM, whatever. So we need a task runner and a task definition inside our automation. Secondly, we need some concept like staging. Normally, you don't just deploy to prod. Maybe you have a peer validation in front, maybe you have some Q&A stages, or you have some pre-prod to have some to your production. So normally you use some kind of staging concept inside your deployment. Then we use variables and secrets. Often the difference between the stages are only the variables and secrets. So I'm deploying to a new Azure resource group. I'm just changing the name of the database. I'm just changing the connection string to your database connection, etc. So we have to deal a lot with variables and secrets in this deployment. Then we need pipeline infrastructure. So basically, an agent is okay, but the agent needs tools. So we need to build some infrastructure around it. How do we deploy our desired tools? What version of Helm do I use to deploy to Kubernetes? Do I need some special SDKs being installed on my agent infrastructure as well to execute the tasks, etc.? Then normally we want to have templates, and this is really a very big feature of Azure pipelines with the new YAML functionality. So they have really great support on an enterprise level grade actually to create templates which can then be used by many other pipelines. So you can really write your code once, parameterize it, and then use it in many pipelines after all. Maybe we also need execution on target. This is also a very important feature. Think of you're deploying a VM and now you need to execute something on that particular VM. So should I open the firewall of that VM? Not really, because you're opening security holes. So what you want to do is actually, after you create the VM, you want to put an agent inside that VM which acts basically from inside out, so you don't need to open any ports from the outside, and the agent is fully functional. You normally have a lot of privilege on this VM with that agent being run locally. So this is also a feature we have a quick look at. How do I do that with Azure DevOps? Then we have approvals going on, manual approvals, automatic approval for some stages. Is it okay to deploy the production environment, and so on. Checks is more or less the same. We can have additional checks. Are you allowed to deploy that on production? From which branch does it come from? What templates are you using? Did you run any successful tests, etc.? So a lot of automation to be ready to be deployed. Then we have different deployment strategies. So depending on the target resources, you can do more than just a simple run this script and deploy it. So deployment strategies mean, for example, with Azure Kubernetes Service, you could interact actually with Kubernetes or even with a service mesh interface inside your cluster to create a canary deployment. So the whole canary deployment is controlled by Azure DevOps, and your pipeline is running multiple jobs to basically add more and more nodes or add more and more traffic towards your new versions, manages your Kubernetes cluster, and this is a thing based on the strategy running in Azure DevOps, so you don't have to deal with low-level things on your own. It's basically just defining a simple deployment and saying, do that in a canary way. First canary is 5%, then 10%, and 20%, 50% and 100%, and Azure DevOps is able to manage that for you. And last but not least, normally we run tests, we run verification tests, we run smoke tests, etc. So we also use this automation to verify the deployment or verify the application if they're running correctly in the target. So all those things, what do we need from Azure DevOps? So first of all, we need repos, meaning Git repositories to store our code, to store our definitions. And we use Azure pipelines to do the overall automation things. Inside that, we could use Azure Artifacts for storing packages. We could also use Azure services like Azure Container Registry inside the pipeline to store our Docker containers. We are using Azure Key Vault, pipeline secrets, service connections to deal with secrets inside our pipelines. We are using different kind of agents like hosted and private agents, but we could also use container jobs to, again, basically have our deployment infrastructure containerized, and the agent is using this containerized infrastructure to run the pipeline itself. And yes, the special feature environments, so everything which is alongside executing something directly on the target VM, doing approvals, doing checks, this is done by environments, which is a sub-feature of Azure pipelines. Okay, so how do we do that? How do we interact with Azure? So normally if you set up an Azure account, you have your overall Azure AD, and then you have your subscriptions, and inside your subscription, you have one or more multiple resource groups. So what do I do in Azure DevOps to actually create new resource groups to interact with the existing deployment? So first of all, we will end up having the Git repository and a pipeline, but this doesn't contain any secrets, any interactions so far. So in order that the pipeline is able to execute actions towards Azure, we need a service connection. So a service connection is basically a feature which is provided by Azure DevOps. So you manage credentials for services. This is very agnostic. You have generic credentials. You have very specific one like Azure Resource Manager service credentials, or you have some Kubernetes credentials to directly interact with your cluster. So normally if we want to deploy Azure infrastructure, we create a service connection, which technically creates a service principal inside Azure AD, gets the credentials and stores the service, the principal credentials inside Azure DevOps. So you have a lot of support there. So you can do that by hand, by script, whatever. But the easiest way is just to click create a new service principal. Normally you have to authenticate again towards Azure, and then Azure DevOps is taking over, creates you the service principal based on your login, stores the secret. It's a matter of a click and a login, and everything is set up for you. Also very important, you can have generic you could have generic service principals, which are mainly filtered by the subscription, or you could even filter more and say this service connection, this can only be used for a specific resource group. So you can narrow down the security that whatever you do in your pipeline, it is limited to a single resource group you defined in the service connection creation wizard. So if we then run the pipeline, first of all, we need to get an agent. The agent is the process actually executing our code, executing our task. And this pipeline agent then gets the credentials injected of the service connection, which is technically as Azure Service Principal. And then you're free to execute any commands towards Azure. So out of the box from Azure DevOps, you have the ARM templates, or generally speaking, just use the Azure Resource Management API. You could use the Azure CLI. So there is a dedicated task to execute Azure CLI. You only have to type your CLI script. You do not have to bother about any logins, etc. This is all done by the pipeline infrastructure. So basically, before your first command is running, it's doing an authentication, gets the tokens, etc. Make sure that you're in an authenticated context, and then runs your scripts towards your resource groups, etc. You can also use other tasks like Terraform, Pulumi, whatever. So there is also a marketplace, an open marketplace. You can install new tasks from the marketplace from other vendors and providers and execute those tasks as well. So normally they have the same concept implemented, that they are using a service connection defined in Azure DevOps, do the whole authentication stuff for you, and then just execute your commands. Again, it is very important to see that the pipeline agent is actually a pretty simple script runner. This one is able to just run scripts one by one, and then present you the logs or present you some other feedback from those tasks. The task itself can be written by Microsoft, or you can also write your own task based on the SDK. And normally the tasks offer more support than just executing a simple script, like doing authentication, doing very complex logic based on a couple of parameters, etc. So if there's a task for your desired purpose, use the task, because normally it's a lot easier. But you could always just start writing scripts, which means you can write PowerShell script, you can write Windows command line scripts, and you can write Bash script fully integrated into the agent infrastructure. This is really a low-level thing, and other than that, you're using those implemented tasks based on the task SDK. Again, a special thing we could do, after we created a VM, we can also deploy an agent in this particular VM. It's running inside this VM, and we could do some VM configuration in a second job. So after the VM was deployed, the agent starts up, registers itself to Azure DevOps, and then we're able to provide a new job definition to this agent, which is then executed directly on this VM. Okay, so how does it look like? So before we go into the technical part, I'd like to show you our best practices, or how does a normal project look like with Azure DevOps when we deploy a microservice environment, which consists of rather basic infrastructure and then the dedicated services. So normally, if we define pipelines, we distinguish between a base infrastructure pipeline and then the service or microservice pipelines or application pipelines, which do the application-specific deployment stuff. But normally, you have some base infrastructure up and running, like setting up an elastic pool in your resource group for Azure SQL, or setting up some Cosmos DB, setting up an overall service bus, whatever. So this is why we use normally an infrastructure pipeline to deploy all these overall generic base things. So normally we have a staging for dev, test, and prod. Why that? Normally, if you change your infrastructure, you also want to verify that this update was okay, that the application is still running. So at least we have two stages defined. So we deploy, first of all, in dev test stage, and then do the prod deployment. To not duplicate the code, it is very important to see that we base that on templates. So we have two stages running the same template, which is just getting different parameters like a different subscription, a different resource group, etc. And normally this infrastructure template then uses other templates because we don't want to repeat ourselves as well. So if we know how to set up an Azure SQL with Elastic Pool, we do that once in a template, providing some parameters for the pool name and server name, etc. And then this template is just called by another template. So this is very important to see that you don't want to repeat yourself and use as much templates as possible, that you have those single parts. The cool thing is, as we will see in a couple of minutes, you can share those templates across your company. You could also do dedicated Git repositories with read-only access for teams, and have like a set of base templates you could use in your company, and all the development teams are just referencing those templates. Then we have normally the application deployment divided in two pipelines. So we have a CI pipeline, which is basically just building the application. This is not only compiling code, this is also creating things like DB schema, creating tests which are used then for the deployment verification. Maybe we need to build up some infrastructure artifacts. We build containers, we build packages, for example, Helm packages. So everything you need towards your service deployment is in this build stage. Uses also templates, so you don't have to repeat yourself on how to compile your ASP.NET Core application, how to create the Docker container image, and so you also use those templates. And then basically we have those pipeline artifacts. Pipeline artifacts can be consumed by any other pipeline. So basically, if I want to do a deployment, I'm creating a new pipeline, an independent pipeline, so I can execute them individually, and then I'm just reading that artifact, those generated artifacts, and do the staging for my application. So normally you have like testing pre-prod and prod, doing all the same just with different parameters. And also what we often use in our projects is a peer validation. So we do a pull request deployment for every pull request, that you can actually access the application, that also a product owner can interact with it, provide feedback, that basically closing the pull request means it's good for production. And we just have those stages like testing and pre-prod to make sure we have a smooth deployment. So basically running a lot of system integration tests in the testing stage on an isolated environment. And the pre-production we often use for complicated deployments, like we have a huge database with huge history, and before applying the schema changes to the production, we do a clone of this database, apply the schema changes, make sure also not the old data is crashing on those new changes, and then we deploy to prod. So this is more or less the overall setup. And now let's have a look, how can we do that in Azure DevOps? Okay, so we use Azure pipelines. This is the module we're using, and you have to understand that basically you have two different ways, the old one and the new one. The old one is not called old, it's called classic. In classic, we have a very specific differentiation between what is a build, so creating something, compiling something, and a release, which is basically the staging, like test, pre-prod, prod, and the ability to consume artifacts from other builds. So this is the old world basically had this very, very strict differentiation. This is the build, this is the release, and that's all you can do. The new way is called YAML pipelines. So YAML is the syntax. You're writing your pipelines with YAML, and they are completely agnostic to build and release. It's just a pipeline, and the pipeline can do whatever a pipeline want to do. So you're not put into this very strict build or release, and you can only do this there. So it's just a pipeline, and you can do everything everywhere. So a pipeline has one or n stages running one or multiple jobs, running one or multiple tasks. Pipelines in YAML can also produce pipeline artifacts. They can publish to feeds, publish to container registry, and any pipeline can be the input resource to another pipeline. So basically, you are completely free how your build chaining is set up. Before, you only had one step in the chain, a build and a release, or multiple builds resulting in a single release. And now you can basically chain those pipelines as you like, and you can consume all the other pipeline artifacts as you would like in your process. You have much more possibilities with the new way. And today we're just having a look at this new YAML definition. But to start, it's still the classic editor, because the classic one has a huge benefit for presentations. It is graphical. The new one is just a YAML file, and you have your text editor open. And here you have a graphical overview. And here you see how this looks like. So the technical concept is the same. You have a build pipeline. Inside a pipeline, you have jobs, and the jobs are executing tasks. This is the task runner the dumb agent is doing. It's just executing tasks. From a release perspective, it's the same thing. You just add stages. So a release consists of multiple stages. Each stage, again, has the jobs, which are executed on an agent, and the detailed definition on what to execute is also called task. So we can also combine them. So we could have classic pipe build and classic release combined with the YAML build pipeline. So even though basically you're free to use what you prefer, but the coolest features personally are in the YAML pipeline. So personally, I think once you start with YAML, you won't go back because now in Azure DevOps, they implemented the most features. So a couple of months ago, you haven't had all the required features to really implement enterprise-grade pipelines with YAML. Now they're there. So personally, I think now is the time to really migrate your whole pipeline infrastructure to YAML. Okay, how does a multi-stage pipeline look like? It's pretty straightforward. You have a pipeline definition, you have stages. Inside a stage, you have jobs and tasks. You can call other stages. You can have multiple dependencies. You could do a forking, a joining, whatever you want to do. You're free to do. You can combine those building blocks as you like, and not only within a single pipeline, you can also combine multiple YAML pipelines together and use the output of one pipeline as the input, also use it as a trigger for the next pipeline, and create a really complex automation solution in Azure DevOps. How are the tasks run? We get back to that later on, but basically the job is the one thing defining which agent to choose. So for every job, you choose which agent should be selected. It can be filtering capabilities. It can be choosing a dedicated pool or a dedicated environment. So here you have to control which agent is actually using the task. Inside the job, this is always run together. So all tasks in this job are run on that particular agent. But you can have multiple jobs, so you can run it on multiple agents, like running it on different VMs, for example, or running it on dedicated environments, so you have a clear separation between dev test and prod, so the agent of dev test is not able to access the prod environment and so on. So this is the important part. On the job level, you decide which agent should be used for the execution. Okay. So what challenges do we solve with YAML pipeline? So one thing is configuration as code. Before, with classic pipelines, it was not possible. So they internally stored JSON as the pipeline definition, but you didn't have that fine-grained control over it. So now with YAML, you store it in your Git repository. You can do pull requests on it, etc. So you really have configuration as code for your pipelines. So code changes might change pipeline definitions. So for me, it is very important to see that if you're creating your application, you have a single repository containing your application code as well as your pipeline code and your infrastructure code. Because if you're developing new features, you need new infrastructure, you need to change the pipelines, you do that in the same feature branch. You can test that feature branch, you can have a single pull request of it, and then if you accept it, it's integrated in master and then rolled onto production. So you really are able now to couple your automation logic, your infrastructure together with your application code changes, and this is what we normally do. We have larger repositories containing application code and infrastructure and automation code as well. So this also solves a problem if you build a very old version, because if it's everything together in the same repository, if you build the old version, you have the old pipeline definition and your deployment will also succeed. And based on those templates we can use, we have no code duplication, so we reuse it, and we have much more possibilities to validate our pipeline changes because it's code, it's integrated in the pull request features, so you have the normal validation features available also for your pipelines. Good. So yeah, let's have a quick look how it looks like. So let me quickly open Azure DevOps. And let's see. If we go here to templates, pipelines, sorry, I can hit, I want to have a new pipeline. I can choose where I store the pipeline, and you see this integration. So it's not only Azure DevOps. If you're using GitHub or Bitbucket Cloud, you can just use another Git provider as a base storage provider or version provider for your pipeline. You choose a Git repository, and then here you have a lot of templates. So Microsoft tried to support you on what you could use as a starting point. They also tried to scan your repository to see what technology you're using and provide you with the best templates they could have. Even though those templates are pretty simple. So if I choose ASP.NET Core build pipeline, you see they did the bare minimum actually. So they just add 2 tasks and it's okay. But let's have a look. So it's YAML. You probably know YAML, the structure. So what do we have in this pipeline? So we can define triggers of a pipeline. So what code changes should trigger a pipeline run, like a CI trigger on the main branch? Which agent should I use for this execution? We can define variables inside this pipeline, and then we will define the steps. So for normal .NET application, what do? We install NuGet, have a dedicated task to update it, to do a Visual Studio build, and run the unit test, and this is our build. So what else is offered in this editor? It's a text editor. It's basically the same editor as you get from VS Code, but they provided some help for you. So basically, you have here on the top right a show assistant, and here you're able to actually add tasks. Like, let's see, do I have something with Azure? Okay. Oh, there's a special task for Azure App Service or Azure CLI. Yeah, let's do an app service deployment in here. And here they present you the metadata, so all the parameters you can use for this task, and then you can go through with help like selecting the right service connection or create a new service connection just inside this pipeline definition. You can then scan for your application services directly in Azure because you're already connected with your service principal towards your Azure subscription, and you have a lot of help here. What this assistant is basically doing, if you put in all those parameters and click add, it simply adds it or inserts it at your cursor position, right? So it's still a text editor, but you have some additional editor on the side to actually help you getting all the parameters, etc. It works also the other way around. If you hit here, settings, it opens again this editor for the parameters with the current selection. So you can change something like, yeah, I'm removing that one. Click add again, and your task is getting replaced by the current definition in your editor. So it's a little bit of help. It only works in this main editor. So if you're using templates, which are other YAML files in your Git repository, you just have a plain text editor, and you only are able to use that editor in your main YAML file, which is created or referenced by your build definition. Okay, so this is basically how you build those pipelines. So how could it look like if you have a little bit of a more complex pipeline? And we get to the feature in a minute. Yeah, I have to hurry up, I see. So basically, this is a pipeline where I'm setting up a complete Azure Kubernetes service infrastructure inside Azure pipelines. So as you can see here, I have a bunch of variables. I'm also using some expression, some if statements to define variables based on a condition. And then I'm starting to deploy it. So this Azure Kubernetes service deployment is pretty straightforward. So what I'm doing here is, for example, I need to create new resource groups. I'm using here Azure CLI. So the pipeline doesn't care about if you're using Azure CLI or ARM templates or whatever. You just need to use that particular task. Here I'm using an Azure CLI task. You see here I'm referencing my subscription. This is my service connection with the service principal. I'm defining a script type, a script location. I can reference a script in my Git repository for that. Or here in this case, I'm writing an inline script. And here you see that's all I have to do. It's like AC group create. I do not have to bother about which subscription to use, etc., because this is all done by this Azure CLI task for me, which does the authentication and the setup of the defaults of the Azure CLI. So basically here I'm creating a new or two resource groups. Then what I also need as a base infrastructure, I need an Azure Container Registry to store my Docker images. I'm just using here Azure CLI, so it's always the Azure CLI task, and I'm executing my script code as defined in an inline script or stored in the Git repository. I could do the same thing with ARM template. I just use the ARM task, reference the ARM template in here, and do the same thing. So basically, my infrastructure deployment is calling a lot of CLI stuff, like creating the container registry, creating VNets, subnets, public IPs I need. Then I'm going over, here I'm creating an application gateway. I'm linking the VNets I created. I'm creating the AKS cluster based on Azure CLI, and so on and so on. and do some Helm deployments, install some tools. This is what I call a base infrastructure pipeline. So here, Azure CLI was the way of my, or the technology of my choice to set up my Azure infrastructure, and I'm just executing task after task to have my infrastructure set up accordingly. Okay, let's quickly switch to the slides and then we go into some details. So I will provide you the slides. So there are some links on what does the YAML schema look like, what's the task reference, what can I use here, etc. So you will get the slide afterwards to have those links available. Okay, so we've seen those pipelines. One important thing to understand is if you have much more or more complex pipelines, you normally use your default text editor. If this text editor is VS Code, you have a plugin or an extension basically providing you all the metadata of Azure Pipelines. So you can change the language mode in it, set it to Azure Pipelines, and then you have all the metadata, all the arguments of the known task will be provided to you with IntelliSense, etc. So normally the big complex pipelines we are creating here in VS Code. Okay, so now let's have a quick look at how we can benefit from those YAML features. So if I move over again to a simple pipeline, what I want to show you is this templating feature. So normally I have a lot of code duplication. So like, yeah, I always compile my application the same way. I always deploy my Azure web app the same way. So let's create a pipeline. So if you have a look at this YAML definition, we see that here in the steps, so the structure of tasks to be executed, we see this template tag. So here we see that I'm using a template build and package web YAML. So if I go to my repository, go to pipeline, build and package web, there is a YAML file defining all the steps I need to do to build and package my web application. Because the web application can be different every time I'm using this template, I can create parameters. So whatever needs to be changed during runtime or during the pipeline definition, I can provide parameters for that. So for example, I can provide a project file. I can provide a build configuration here. Which path should I publish the application to? And then inside the tasks, I can use this parameter syntax or expression syntax to actually put in the value of this parameter. So again, here we see that I'm creating here, or I'm using the pipeline build and package web, and I'm here using variable of this specific pipeline, how to parameterize this template, and I can reuse the code. Also, it is very important to see that basically, if you have some standards in your company, you can put that into that template. You can enforce them. We don't have time for that today, but basically what you can do, you can enforce that only an application can be deployed to your production environment if the build pipeline has used this template or has been inherited from a template. So you can also use like inheritance, saying this is my base template, and if you don't inherit from that one, you're not allowed to deploy to production. So large companies make use of this template inheritance and template checks very often because they can guarantee that you always deploy it the same way. Another very important thing to see is we have here this special pipeline definition. So the difference is here at templates repo. So what is this? This is a pointer to a resource. So in addition to that one before, which is in the same Git repository, I'm creating here a Git resource which is used by this pipeline. So instead of just using one Git repository, I'm using more than that. I'm using an additional one. And this is the Git repository name. I'm using. So this is the reference. This is the path to Azure DevOps repo. So there is a Git repository inside the same Azure DevOps project, and I'm able to load a very specific reference. So let's see. I'm switching over to my company-wide templates repository. What we can see here, that basically I just created templates here for validation, for versioning, all the things I want to do the same way over and over again. And here I also created multiple branches, like we have our main branch, we have the release branches, different version. So the important thing here is if I have a common repository for storing all the templates, if I'm changing a template, I need to make sure that I'm not crashing all the existing builds. So this is done by this reference name. So I can reference a branch, a tag, whatever, to have a very specific version of that template loaded from another Git repository. So basically, I'm now able to have this centralized templates repository for my team, for my whole company, and inside the pipelines, I can reference an explicit version of it to make sure I'm not breaking the build with new versions released of the pipeline. Okay, so let's move on. So what can we use template for? We can use templates for steps. So I have a couple of tasks or a bunch of tasks running always together. I can create a template out of it. I can create templates of a complete job. So the thing executing multiple tasks on an agent. I can even do templates for whole stages. So I could have a stage template and then have it reused for dev, test, and prod, for example. And I can also have variable templates. If I really have a huge bunch of templates, I can create variables. I can create a template for those bunch of variables and then just reference them in my pipeline. Okay, so let's quickly move on. I add more slides than I can show you today, but I'd like to show you a couple of things. So the multi-stage pipelines is nothing very special. I'm executing different stages, be dependent on each other, like here, or they can be run in parallel as well. But this is the normal thing you do in deployment. You want to have a single pipeline, implementing the staging, make sure you have some criteria like approvals, like checks, to be able to run in the next stage, controlled way of deploying your application. Okay, so let's have a look at the other features, variables and secrets, and now a very important topic. So basically you need variables in a pipeline to define where to deploy to, what's the name of the application, etc. Important to know here, you can see I can basically construct variables out of other variables. So I can simply compose variables based on other variables. And I'm also able to use expressions. Like here, I'm calling a function which is provided by Azure DevOps. Here, I'm doing a string format to do the same thing as the one above. But you can also have if statements in it. You can loop through things with expressions, and a couple of them are also able to be used inside the variable definition. The drawback of that, having variables in the YAML file, it's the readability. It's indexed, it's in your search index, it's basically everyone can read that. So it's not the way of dealing with the secrets. So one thing you could do is actually create secret variables on your pipeline definition. So there is a logical pipeline definition in Azure DevOps, which references your YAML file. And in this template definition, you can also create variables here, and they can be secret. So they're injected at runtime. They are extracted from the logs. So if you print a secret variable, you just have *** in your log file. They cannot be directly read from a script. So there is no way you could create a script saying, give me all the variables available, those secret variables won't be part of it. So you have to explicitly provide them to a script in order to read them. So Azure DevOps makes sure you store your secrets secretly inside Azure DevOps, and they can't be accessed that easy by just running a script or reading the log files. In addition to that, normally, if you have more complex solutions or you want to have an integration with, for example, Azure Key Vault, you're using variable groups. So instead of defining your variables as we did before, you can also have a group reference in your pipeline definition. This basically points to a variable group, which is managed by Azure DevOps. And here you can define all the variables you want to use. The cool thing here is now that I'm able to link that to Key Vault. So I can say, hey, this is a new variable group. I'm linking that to a specific Key Vault. I can select the secrets I want to read from the Key Vault here, click OK, and then during runtime, I just have a normal pipeline variable available. I can interact with that. It's the same thing as the secret variable we've seen before. So it's not printed to the logs. I cannot access it, but I do not have to deal with Azure Key Vaults inside my pipeline logic. I'm managing that on the outside, creating a variable group which is linked to Key Vault, and I'm just referencing this group in my pipeline and have a very, very good way of interacting with the Key Vault. The coolest thing, personally, we're doing now a lot of things with managed identities. So we are setting up managed identities in Azure, so we do not have to deal with any secrets at all. So basically with those pipelines, we just have plain text variables because all the authentication happens through managed identities in Azure, and the pipelines basically just have public variables like a connection string without the user and the password for that reason. Okay, then agents. What's offered by Azure DevOps if you want to do that? So basically, if you're thinking about what agent should I use, you need to decide, do I run my own agents? Do I manage them on my own, or should Microsoft do that for me? So if you want to do that on your own, you have the self-hosted CI/CD. If you don't want to do anything, you have the Microsoft-hosted CI/CD. Microsoft-hosted CI/CD is basically a VM already prepared for you. There are a couple of base images they prepare for you. So there are images for Windows, for Linux and Mac with different kinds of operating system. They have a standard set of tooling, and they're always available. So it's like a virtual agent pool. They always have some VMs running for you. Then you get a VM, you execute your pipeline inside this VM, and then the VM gets destroyed. On the other side, on the self-hosted side, you are responsible for creating those agents. So you set up VMs, for example, in your own data center, you create a VM in the public cloud, in Azure, you're installing an agent in this VM, and then you're registering that agent to your Azure DevOps instance. The benefits of having the self-hosted ones, you can install just the tools you like or you need. You can do a lot of caching because you normally have a state. Your VM doesn't get deleted after a pipeline run, so you can improve your caching, so you have faster pipelines, etc. if you do it on your own. So what you get on the basis, if you create a new Azure DevOps account, you have one parallel job license included. So for every other parallel execution, you have to pay, you have to buy more licenses. On the hosted side, you basically have 30 hours of agent runtime per month for free. And you could also have dedicated agents. So you could also have your own VM set in Azure, which is then managed by Azure DevOps if you want to have your own VMs, dedicated agent VMs. So you have those 30 hours per month included, and for sure, whatever you need, you can just buy more license or buy more additional hosted agent. So a hosted agent is about $40 a month, and you can run 24/7. for these 40 hours. It's just one parallel execution. And the same thing on the other side. If you want to have multiple agents running, you just need to buy licenses. I think they're about $14 a month to have additional parallel job licenses for your private agents. And then what else do we have? So we have those different pools, the host pool and the agent pool. So if you're using a job, you can choose an agent pool or a hosted agent pool. If you're doing a deployment job, this is basically just a specialized job, which is able to do other things like the canary deployment stuff, etc. You also have access to the agent pool and the hosted pool. There is an additional pool type like a server job. This one has no agent at all. So if you just need to check an API like were the tests successful, do we have any errors on application insights, you do not need to provision an agent for that. So this is called a server job. And basically the only things you can do is run REST calls from Azure DevOps. So this is directly executed in Azure DevOps and doesn't require any agent at all. Last but not least, if you have this environment VM type, so you place an agent in this particular VM, you have a deployment job with a resource type virtual machine, and then Azure DevOps makes sure that it accesses all the agents of all the deployed machines. Like if you have a setup of 3 servers and you want to have the same deployment on those 3 VMs, you could say, okay, run that on this environment, and then all the agents would be started in parallel. The same deployment would be run on all the agents from inside out. So it really runs in the VM, so you don't have to open any ports, etc., from the outside. Okay, so this is the last part. We need to know those environments. So this is a management view of what you deploy. Whatever you define as an environment can be defined by creating an environment, like having a Kubernetes namespace as an environment, for example. Or you could say, yeah, this is my web infrastructure as an environment. And then you're able to interact from the pipeline with those environments. So you can see what was deployed to. You can actually get details of the deployments based on that environment. And this is only supported for 2 types of environments currently. So there is this generic none. You basically can't do special things. Then they have an implementation for Kubernetes and virtual machines. Kubernetes provides you special deployment strategies like canary deployments and so on, which integrates into the service mesh interface of a Kubernetes installation. And the virtual machines one are those I'm deploying an agent directly to this VM to have this inside-out task execution, and I can control a bunch of VMs. Like I have 3 similar web servers, I'm deploying to all of 3 web server the same deployment, and so on. Or you can also do some rolling updates, saying, yeah, I want to only update 25% of my environment, and then 50, and then 100, something like this. This is only available for those 2 types currently, and hopefully much more will come in the future. Then the last thing we have to have a quick look at on environments are approvals and checks. So as I told you, we have a lot of enterprise-grade features in Azure DevOps. So first of all, approval is a standard enterprise thing. Before you deploy to this environment, to this stage, the manager has to approve. Before it goes out of QA, the test manager has to approve. So those are just manual approvals. You have to specify your Azure AD groups, security groups, or specific users there. And until they don't approve, it won't be deployed. Then with branch control, so you can make sure, for example, that on the production environment, you can only deploy from a master branch and not from a feature branch. You can also make sure you're only deploying during business hours. So basically, you can postpone the deployment to a time range where everybody's working. So if something happens, everybody's there. So for example, if somebody is checking in at 1 o'clock in the night and everybody's sleeping, you could postpone the production release if you feel unsure about it to your business hour and make sure it gets only deployed within the business hour. Then you can do artifact evaluation. This is currently only available for Docker. So you can inspect the Docker image and make sure that it is a qualified image, that it has consists of the right layers, etc., and not a very strange, not validated Docker image is deployed to your production environment. So this is a Docker-only feature currently. Exclusive logs is that you just have a single deployment going on. So for example, if you have multiple triggers going on, you can log a resource to a deployment, finish it, and then the next deployment can start. So you can prevent that multiple triggers deploy into the same environment by locking it. You can run Azure Functions or REST APIs. So if you have a dedicated monitoring tool, you could say, I'm calling this API, and if the error count is 0, you are able to deploy. If the error count is greater than 0, you're not able to deploy to production, for example. Same thing works for the Azure Monitor. It's just a little bit a more sophisticated API, but it does the same thing. You check an API, and if you have a positive value, you're able to deploy automatically. And last but not least, required template. This is what I told you before. If you're using templates, you can also use a template inheritance. And here you could make sure that the administrator is saying, in our company, there is not a single pipeline being deployed to production if it's not inherited from our base pipeline where we check that the code is okay, that we have security scanning enabled, etc. So you can enforce the usage, the inheritance of those YAML pipelines for the developers. They can create other pipelines as well, but they are not allowed to deploy to that particular environment if they are not using the inherited pipeline. Okay, so I'm almost running out of time. Let's have a quick Q&A for the last 15 minutes. Are there any questions to what you've seen?